We are live. Hi, this is Toby. Coming back from lunch. Trying to fix this. Wait, let me. Um, I'm trying to pause this playback here. I'm not sure if there's a pause button. Sometimes there is, and sometimes there isn't, and that's kind of confusing. Okay. I guess if it doesn't work, I won't try it. Okay, sorry about that. Okay, I'm back from lunch, and we were trying to solve this problem last time um, by sort of taking the box or the taking the subscopes. So let's say the main function call is one scope, and then when we call another function within the main function, that creates another scope. We're trying to say we just detect the nested scopes in case we zoom in so far in that the FIP7 scope contains all of the viewport, then we'll just say that is the current scope, and we'll avoid um, we'll avoid using the main as we'll avoid using fit box on the top level scope, and we'll only use it on the current scope. However, over lunch, something dawned on me. It dawned on me that there could be a way of fixing this problem that's much easier than doing that. So I'm actually gonna switch directions um, and go for the easier solution here. So I'm gonna the code that I wrote on finding the current scope, I'm actually gonna go ahead and undo that or comment it out. I think there was this code here. Code trying to implement current scope. Okay, I'm actually gonna not do it that way anymore, and instead, my idea is actually to fix measure text for the case where it's broken. See, the problem with measure text was that whatever is implementing measure text, it put a cap on the maximum font size. And they basically said, and I figured this out by trial and error. Basically said that maximum font size is 10,000, and that seems like an arbitrary number. they thought there was no way in hell anyone would use a font size that's more than 10,000, and I guess I'm here to prove them wrong. But actually, a simple way to get around this is just by scaling. In this case, I think scaling is totally justified. And in the case of this particular font, I guess it doesn't really matter for other fonts, but for this particular font, because we're using a monospace font, we don't even need to do measure text. We could have simply done a division. We could just, because it pretty much told us that the font size is half of, the font width of any character is half of the height of the character. So we could have just done the length of the text, like the box.text.length times the width divided by 2, and let that be it. I realize that only works for this particular font. You know what? I'm gonna do it as a quick test to see that. Font size divided by 2. And if that works, as in if I, well, okay, that's a little weird. But this should allow us to continue. Oh, it might need to be +1, maybe. I think that fixed it. Probably also allows it to be faster. Yeah, that totally fixes the problem. So now we can zoom in any number of levels. Yay! Kind of, okay. And finally we have here down to this level. Yeah, I that took me like 2 seconds to implement. Rather than like giving a lecture, then like taking hours and hours to explain the problem. That just took me 2 seconds to implement. But okay, a slightly more sort of well-rounded solution to this problem is instead of doing this, that I guess would work for the in Consolata font only. So if I were to make it work for any font, I would probably take the width. If the font size is, I might do this like. Well, let me just do this first. If the font size. Now let me just get the measure of this. If the font size is greater than 10,000, then we need to do the adjustment to the width, which is that. Actually, I know it's measuring it based on the size of 10,000. So the actual font size, I need to scale it by like what it is supposed to be. So if at the font size of 10,000, so like I said, well, let's do a smaller string. A, B, C. I'm gonna scale it up basically. If at the font size of 10,000, it's gonna give me 5,000 plus 5,000 plus 5,000, which equals 15,000. But I actually need to scale this up. So because if the font size I actually want to test is like 30,000, I actually want to multiply this by 3. So this should be font size divided by 3,000 to get us this factor. I'll call it F. And now I want to multiply this factor by whatever the width number is that it gave me. So that's what I'm going to do. Then I'm going to say width. I'll change this to let so I can overwrite it. Width is going to be equal to width times this factor, which is coming from font size divided by 10,000. I think this should do the trick for us. This will be slightly slower, I believe, than the previous solution. Yeah, but this works just as well. Yes. This zooming is less fast. And you know that's a problem. The rendering code feels a little sluggish now. I'm sure a lot of that has to do with this measure text thing. This measure text code, the native implementation of measure text is actually somewhat slow. But I think I can optimize that. So in any case, I got this kind of working now to the point where this zooming algorithm can zoom into any number of levels. Fib0 and Fib1, and then if we zoom into Fib0 and Fib1, I feel like the performance problem is a bit of a problem. So perhaps, well, let me think about that. But where for the zip1 one, it went to the return1 branch, and for the Fib0 one, it went to the return0 branch. And that is super cool. And it zoomed all the way back out within very little time. I'm actually gonna try not doing the update log and see if that can improve the performance a little bit. I feel like performance is getting sluggish, and if that's the main thing I'm worried about, perhaps I will do some work on the performance of this thing. Like it seems a little jumpy, not smooth. But I do love that we can zoom into very, very deep now, even though it's not, yeah, again, not very smooth. Okay. Cool. So, let me see. I'm gonna take a look at the old to-do list, actually. I'm gonna call this fixed, actually. Done. And performance problems is the next thing that's staring at us right now. And yeah, let's work on a performance problem. So this will be a good sort of performance tuning video. It could turn out to be that way. So front-end performance tuning is something I've been doing a fair bit recently in my mentoring work, and yeah, this could turn out to be one of those. So Chrome DevTools has really good tools now for performance tuning. So you want to go to this performance tab, which will allow you to do CPU profile captures. When you turn on this button, it basically records all your JavaScript execution and also extra stuff the browser is doing as well, and it'll graph it in a heat map. Or is it called a heat map, or is it called a flame graph? I think it might be called a flame graph. I'm just gonna show you. You hit this button, you do some stuff that might or might not be slow, and then you're gonna stop recording, and then after that it'll generate this report for you. Okay, so I'm gonna zoom in. And the goal for me is I want this zooming to look very smooth, silky smooth, like a baby's butt, so that this user interface feels very interactive. Okay, so we zoom all the way down now. There's no more to go. Again, if I zoom even more in, then I'm just gonna get this text to be bigger and bigger. Okay, I'm gonna stop there, and we can look at this flame graph, and the flame graph, if we know how to read it, it will tell us what are the slow parts. So first of all, this guy here, that's the CPU utilization graph. this guy here. It does say CPU over here. So this is the CPU oh, I misspelled utilization. Utilization graph. Come on, I cannot spell graph. Okay, this guy here is CPU utilization. Here is 100%. So here is 100%. That's when the CPU is peaked. If it's down here, it's 0%. So you can see there's a number of places where the CPU utilization is at 100%. Here, 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 all these places. So many times over, the CPU is having to work really hard, and that's why we have things that feel slow. And also the rendering on the screen is not able to keep up with the zoom events, the mouse wheel scroll events that are asking for it to re-render the display. The yellow pieces are the JavaScript execution. So you can see there's actually a lot of JavaScript execution. And down here, I'm calling this the flame graph. I think that's what it's called. This is the flame graph, and if we drill into the flame graph, we can actually see a lot of details about what the code is doing. So let's go ahead and do that. This flame graph, this flame graph, I would say, is partially the inspiration for what I'm building, because this is a zooming user interface, much like Google Earth, and much like what I'm building right now. Also, I want to mention that there's this sliding screenshot history of screenshot, which is something I would like to implement as well. This is an extremely useful tool for troubleshooting debugging, because you can hover over any part of the timeline and see what the screen looked like at that point. Okay, so I'm gonna zoom in here to these slices, and each of these slices is a stack of function calls. It's very related to what we're building right now. Actually, I'm trying to have this deep zooming visualization illustrate the execution of code, and this CPU flame graph is doing the same thing. I guess I'm trying to take it even a little bit further than the flame graph. So here we can see that there were several render function calls. Each one of these horizontal slices is a function call, and the stack is actually the way to read the stack is, I'll drill down a little bit more. The relationship between when you have two slices in this stack, in this layered cake, the slice above is the parent function, and the slice below is the child function. So this means whatever this function call is, it called render, and render called render frame entities, and render frame entities called render frame entities. Rendered frame entries, not entities. Render frame entries. Render frame entries called render frame entries, and this render frame entries called fitbox, and then it also called render frame entries, and so forth. So this is a call stack, basically. This is basically a call stack, but what it has that a normal call stack doesn't have, it's got these time durations. My computer is frozen right now. How is the stream? At least my browser is frozen. Oh, it's not that it's just that I was in my drawing mode mistakenly. Okay, So it's got all these time durations, and this tells me that render took 338 milliseconds to execute, which is a little bit less than half a second. Which makes a lot of sense to me that this feels slow, because ideally you want you want your render process to render something like between 15 frames a second to 30 frames a second. So if you want, if there's a 1000 milliseconds in a second, which there is, if you divide it by 30, 30, if you want 30 frames a second, you're gonna need all of the render code to execute under 33 milliseconds. And currently it executes in 439 milliseconds, which is nowhere close. If you want 15 renders per second, then you're looking at 66 milliseconds, which again, this is nowhere close to that. So let's drill in and look at what the slow parts are. And I can already see that the slow parts, the red parts, the leaf nodes in this stack graph is the measure text. The measure text is the thing about it that is the slowest, and we should optimize that. The idea I already had is that, hey, if I know that this is gonna be, if I know that this is the in Consolata font, then I can actually just hardcode this value, not hardcode it, just assume that it's always gonna be the half of the font size, and we're done. And perhaps we might try that, and then do another reading with a flame graph to see like how good a performance we can get as the result of optimizing away this measure text call. Let's just do that and see. So I believe what I did before was I took the text length multiplied by font size and then divided by 2. If I did that, we had about 430 milliseconds right now, and now this feels much faster. It just feels faster, and there's a little bit of a bug here, but I'm gonna deal with that later. Okay, so I'm gonna zoom in. Keep zooming in. Zoom all the way until fib of 1 and fib of 0, and there's our code. I'm gonna stop. Okay, so these, we still have 100% utilization in some cases, but the yellow part is actually not as pronounced. I'm not 100% sure what the gray parts behind the yellow is, actually. Maybe I can get an idea by zooming in here to this. There's these task thingamajiggies. Okay. It probably means each time the task happened, the browser is trying to re-render itself. And now if I look at the render, for this render is taking 136 milliseconds. This one is taking 75. So definitely much better, but still not down to the 33 milliseconds that we are dreaming about. But nevertheless, we can drill down and try to figure out what are the parts that are slowest. Okay, and this part is saying that the fill text now is the slow part, and the measure text is no longer the slow part. We see measure text nowhere inside this graph, and that does confirm that we've removed the previous bottleneck. So whatever we did help. It reduced down to something that was like 430 milliseconds down to around 80 milliseconds, sometimes 100 milliseconds, which still is not great, but at least, let's see, at least that's one large piece of the performance problem solved. So, okay. So I think what I'm going to do is, because that's such a good performance improvement, let me think. We could, another idea is if we knew the font was monospace, we could do this enhancement where all we have to do is call measure text on one of the characters, and then just use that as the number for and scale it up, I think. Let me think. I'm gonna play with this and see how happy I am with this. Obviously, I still want it to be faster, despite this working pretty well right now. I might still want it to be faster, although maybe this is enough for now. It feels kind of fast, actually. Okay. Let me think. Why is there this bug? I'm gonna try to fix this bug where there's this measurement of the text is slightly off. And it feels like what I'm using feels right. It's the, because for I'm gonna test out the properties of measure text in an isolated way, and I think the way I did it was here. Okay, so with Inconsolata, is my formula correct? So if I have 100, then the width should be 50. What if I give it hello world? There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters. In the case of there being 12 characters, yeah, so it should be 12 times 100 divided by 2. So my measure text would have been font size times I divided by 2. So my width, I'll print out my width. That's my algorithm to measure the width and see how it compares with the normal measure text. So far this actually looks correct, unless, wait, oh, this code that I did turn this off. So I don't actually see what the problem is. I think I have replicated the algorithm. Oh wait, there are some differences. Oh, that's because it went over 10,000 though. This still looks correct to me. So I don't understand why this is not working actually. That feels like it should work. But why is this guy sticking out here? Maybe I could do something that's simpler, like okay. I'm gonna call the fitbox algorithm just a text box. And I need a type of text. And it's gonna need a bounding box, which I'm going to say 0, y0, width is 1200 and height is 1200. And then code font family normal, and then the context. And then after that we have to render now. Okay. Wait a minute. Let me think. We fit this box inside our... Oh, I see. Our box has not been converted into sort of world view. Screen box is box world to canvas. me try this. Okay. It spilled out. Why did it spill out? There's one thing before I forget that I realized, which is that we don't have to be setting this anymore. If I'm using this calculation, it doesn't depend on this font being set. So I could remove that, which might help the performance, maybe. Oh. But then we will want to set this font before the render. Yep. And Fitbox would need to tell me what the font is as well. So, let's return. Uh-oh. I'm gonna move these lines in. I'm gonna undo my refactoring that I did earlier today. Change my mind. So I'm gonna move this in. I'm gonna call render with the bbox map that we have, and then the box. But the setting of the font size will be done here. Just once, instead of many times like this. We could probably do it like this. That should have done nothing. Yes, okay, that did nothing. I guess I was hoping that it will make it even faster. But I don't think, wait. One of the parentheses protruded outside of the box, and yet it did not notice that, and I don't know why. I'm actually gonna undo this change because I don't think it's related to this bug. Or is it? Okay, I'm gonna work on this hello world. Yeah, let me work on this hello world example, and I'm going to basically get rid of this render code so that we can't sort of go into the normal mode. I only want to debug this hello world problem. So I want to step into this fitbox function, and I'll put back in some of the console.logs I've been using to diagnose it, and I will explain again how this guy works because I'm trying to debug it. Okay, so basically it's not printing the didn't fit, which it ought to do if it didn't fit. If it did all fit, oh, it breaks. Break out of loop. So this is a technique of debugging that I use. I just put console.logs in the code in strategic places to try to follow the path of the code. But especially if there's a if statement, I try to put console.log statements in both branches. Oh, well, I did here and here. But I didn't see they didn't fit, which I actually did expect that to happen at some point. And not seeing didn't fit kind of surprised me. But now I do see it. Okay. So when we tried font size 5 to fit Hello World in the box, it all fit. And 10 all fit, 20 all fit. It's when we tried 160 that it didn't all fit. And then it would bump it back down. 120 it didn't all fit. And then when we went to 100 it all fit. 110 it didn't fit. 105 it didn't fit. And then font size 102 it also didn't fit. Finally we tried 100 and then it all fit. So the font size we ended up choosing is 100. However, when we actually rendered it, it actually came outside the box. So let's figure out why. So when we're trying 100 here, which we had already tried once before actually. So we should not have tried to do it again, in fact. Okay, but I did try to lay it out with font size 100 for some reason. So there might be another bug inside this algorithm. Maybe that's kind of minor though. I think we need to get into this layout function and figure out what it was doing. So maybe it's not correct that font size of 100 should fit in here because this box is, what is the size of this box? This box should be 600 by 600, I think. Let me print out the screen box. Kind of hot today. I'm opening up the window. Okay, yeah, is 600 by 600, and if we did, if this is 100, this guy is 100. I have to say, this doesn't feel like half of this, although maybe it is. Okay, maybe it is. Okay, so this is 50, 150. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 times 50 is what? 550, 60, 70? 2 times 5, 700. 700 doesn't fit into 600, right? Let me just double 12 times 50. No, 12 times 50 is 600 actually. Oh. Huh. So let me, I can't do math. Okay, so 600. 12 times 50 is 600. Is that true? Yeah, yeah. So the calculation is actually correct, but why is it that when it's on the screen, it expands beyond the font size? That's weird. So I'm going to go ahead and it's trying 100. Here, maybe I'll print out the final font size at some point. I did print the font size here. I'm gonna do this one more time. Maybe? Nah. It was trying font size 100, then it breaks out of the loop, and now we're using font size 100. Let me just do this one more time. And again, it should not affect it, but I just want to double make sure. Okay. So this is weird. I'm actually going to use my image editor to try to debug this. Okay, so I'm going to do a screen capture from here to here. Pixelmator. Okay. So let me see. I show grid. Oh, I have these X and Y coordinates here. So this is 300 by 300. I can probably zoom in. Okay. So this, here that's 300 by 300. At the end of the H, we got 361. Here we got 420. After the L, I have 480. 480 divided by 3, that's 160. It feels like the width is actually 160. For the height of here is 400, subtracted by full. It seems like the width is actually 60, not like 60% instead of 50%. That's what I see. But why is it that I don't see this discrepancy when I call measure text? Because it maybe I'll do this. I'll do their width and also my width. And if their width is not my width, I'm gonna throw. Actually, I'm gonna do a debugger here. And then I guess let's use their width, which will be slow. But yeah, it totally works with their width. And it did pause in the debugger where their width and my width are not equal. Okay, and right now the font size is 5. Oh, so perhaps it's actually for, because I didn't do anything less than 100. So maybe I need to do like start from 5. I'm gonna do 5 to 300 in increments of 5 actually. Oh. No, it still works. What the heck? This still works. I might be doing something wrong in here. Did I spell inconsolata wrong? Oh, I did spell inconsolata wrong. Shoot. Jesus. Okay. Alright. God. Alright, that was a large blunder. Just one misspelling of the font name caused this big misunderstanding. Okay. But I guess the upshot of this is that now I can't just divide by 2. But we still hit this limit where, let me see. Wait a minute. Oh, Monaco. Oh, we're using Monaco. Where do we have Inconsolata then? Wait, Monaco doesn't have this threshold problem. What? Okay. Okay. Okay, that makes me feel better. It just tops out at 10,000 as well. Okay. Okay, so I guess what that really says to us is that for measuring text, I would like to try this strategy though for measuring text. Yeah, let's say for Monaco. Can I just take the width of, because this is a monospace font, to fixed width font, that means every single character has the same width. So I actually don't have to ask it to measure the width for me every single time. So I should be able to say, if I measure the width of that should be the same as saying, hey, can you measure the width of just anything, even a space will do, multiplied by the length of the string. Oh, I just lost my place there. Dang it. Where was I? Okay, there's my string. I'm going to ask you to measure the width of my whole string, or I'm just going to measure one character out of the entire alphabet, measure its width, and then multiply it by the length of the string. Do we get the same answer? I think we would get the same answer, and if we did, where is the 199? Oh, here. Let's just say, I don't know, 35 pixels for now. Yeah, we get the same number. Should we get the same number for 5 pixels? Yeah, I'll make this string more representative, like I'll put in all of the alphabets and some special characters about numbers as well. Let's do the symbols. Yeah, and see if they're equal. If they're equal, then I could do a very, very good optimization for fixed width fonts. I'll do 100, 110, which is we're just gonna measure one, yeah, just gonna measure one, the width for one of the fonts. Okay, yeah, let's do that. So I'm going to probably write a function, write a custom custom measure width function, custom measure text function. Let me think. The purpose of this setting of the font is just to measure the width, I would say. I'm tempted to, yeah. Okay, I'm gonna do this. Make a custom function to measure text width given text, because I'm given some text. And the font size, which is a number, and whether or not it's fixed width. There's a boolean. I think I'm gonna make a dictionary and cache the result of the measure text calls. Should I do that at this point? Let me think harder. I made this text measurer, which was used for this, which has a cache within it. Is that in, yeah, it's in here. I could use this. Maybe I just use this guy instead, but have a special optimization for the case where it uses, where the font is fixed width. How do you know if it's fixed width? How do you know if a font is fixed width? That's a good question. Maybe we can test it. Like if I is the same width as big W or something like that, then it must be fixed width, right? Interesting idea. Should I do that? And then we'll use this text measure here. It does need a canvas context. And then I have to give the layout engine the text measurer as well for this optimization. let me think about this. Should I make this text measure more generic or less generic? That's what I'm trying to figure out. The way this text measure works is it caches the width of every single character. And I guess we can see that if I and capital W have the same width, we'll say it's, and then we won't bother. So we'll have to change the implementation of this thing quite substantially if we were to do that, though. Or we could, maybe we could do this. We can have a variable width text measure, but we can also have a fixed width text measure. But then should it sort of assume a certain font family at the beginning? Okay, I think what I'm gonna do is make this text measures behavior slightly more fit, make it fit more with how we want to use it. So I'm gonna have a method called set font settings, or set font perhaps. And which is going to do this. And here, when we do this, we're gonna do that. Set the context font, and so that we don't have to do that within this loop. And measure text no longer takes this font setting. Probably we can also just pick this guy. Well, font setting can just be the font string. Can just I'll just like font is a string. I'll also set my font to the font string so that we don't have to ask the context for it. And then here that can just be this.font. Okay. And also we'll try to figure out whether it is monospace fixed width or not, which is a boolean. So how are we gonna figure out whether it's fixed width or not? We're going to measure the width of I and the width of capital W. They should have different widths in variable width fonts, I would think. And then we'll also just like stick them in the width table. Just in case, that might be useful. And then we're gonna then this dot fixed width is equal to I width is triple equal to W width. If the width of I is same as the width of the capital W, then I'm gonna say it's a fixed width font. And if it is indeed a fixed width font, then I'm just gonna say if this dot fixed width, then I'm gonna do a different path than if it's not. If it is fixed width, I'm gonna just say return the length of the string times the width of I. Yeah, and let that be it. Yep, I think that works. I'm gonna try this. I'm gonna have a text measure, which I already have. We're gonna need to set its font settings. Actually, I'm just gonna go ahead and pass in the string because I kind of feel like there's no point in having that font setting object anyway at this point. Okay. All right. And then I have to give the text measure to the layout function. And then use the text measure instead of this. And perhaps maybe it's just a measure. And perhaps this logic can also be rolled in to the text measure. I'll just call this, rename this to measure, and I guess if the font size, oh shoot, I don't have access to the font size. Maybe I'll leave this here. No, I can't leave this here. I'm gonna ignore this problem for now, which means the variable fonts will break. But actually I could, one sec. I'm just gonna undo and get my font setting object back. Because if I had my font setting object, then if I had my font setting object, wait, nope, that's font string. Okay, if I have my font setting object, then I can actually say, ask what the font size is. Here. Okay, so I can say I can say this conditional here. So if the this dot font setting dot font dot size is greater than 10,000, then total width should be total width multiplied by the font size divided by 10,000, because measure text is doing that instead. Yeah. Oh, the character key is actually. Oh, okay. This character key. Okay, the character key is actually the character plus this dot font. That way it doesn't collide with the same character in a different font. Okay, so let's pass the text measurer. In here, so this should not be needed anymore. So I'm gonna pass a text measurer here. So text measurer dot measure text, and then whatever it says is the width, I will trust it here. This is only layout, so I think the only thing it was using for the context was for the measuring of the text, and now it no longer needs that because the text measurer will do that job. So I don't need to pass in. I guess I'll look at the compiler window for failures. 210. Yep, it doesn't need that, but it needs the text measurer. And now it's 180. Okay, 110 now. That's an error. And here is saying it doesn't want the context anymore. And then I cannot find something called font size, line 78, which is here. This needs to be this dot font setting dot size. Does it even know what font setting means? I don't know that. Font setting is something in another file. I'll let it complain about it first. Line 58 is here. It says I don't know anything with the word name with in it. With white. Okay. That seems to be extra code carried over from somewhere else. Okay, font setting, great. I was worried about that. So font setting is just that, no worries. Yes, okay. So I'm trying to assign something of string to font setting. That's not working. Okay, got it. So I'm gonna need weight, which is the font weight, size, which is the font size, and family, which is the font family, and inside of a font setting object. It actually compiled this time. Okay, so this is kind of exciting. Let's see if stuff works. No. Oh, because I had all the code commented out except for this little tiny example. So I'm gonna. Oh my god, this code is so messy. It is so messy. Okay, I'm gonna go back to the deep zoom code, which seems to have compiled. Whoa. It's trying font size 0. Shoot. We have some major bugs. Major problem. Houston. I'm gonna try to solve a smaller problem first, then. Compiled. Okay, so this one is saying I want to just render hello world on the screen. Will you do it? The browser might be dead, so I might want to kill this. Okay, I'm thinking we have an infinite loop situation right now. Whew. Okay, so one trick I use to deal with infinite loop situations is sleep. So I'm gonna import this sleep module. Simple sleep is a very small module that I wrote a while ago. It'll allow you to wait for a certain amount of time. I'm gonna do that in here. And that'll allow the browser to not freeze up entirely, I think, while it's infinitely looping. And then hopefully I can somehow diagnose the problem after that. Alright, let's try this. Okay. May need to kill this process first. What's going on? So it's trying font size 0 over and over again for some reason. So it says for font size 5 it didn't fit. I guess I need to know why. I suppose for if the font size is 0, we should break out the loop to avoid this infinite loop here. So I'm gonna say if font size is 0, throw new error. Unexpected condition. This should never happen. So let's see if this at least allow us to not have an infinite loop situation. Let me kill this guy. Oh wait, it doesn't like my code. It says, oh, okay. I didn't make this async await function. Okay, at least that will do it. Let me try this. It's just an error here. Yes, okay, awesome. Yeah, alright. Now at least I don't have an infinite loop situation. We can actually work somewhat productively after this. Alright. So that must have something to do with the fact that we plugged in our new font text measure and it probably wasn't doing its job properly. Yeah. So I'm going to, I guess, look into the inner workings, or let's see. All right. Measuring text box.text, and then it's giving us this width. Oh, I already had this console.log. I'll just reuse that one. Gave you a not a number. That's beautiful. Okay, so how does that give you a not a number? Oh, I need this key, obviously. Oh, it actually worked. Okay. All right. Now we're gonna go back and do our performance reading. I'll comment out these console.logs. And also, let's see. Let's revert the app back to the normal interface. Okay, which does look like that. I'm gonna take out that console.log that says measure text. Here, get rid of that. Compiled. Okay. And I want to see, oh, I want to take out this breakout of loop as well. Where does it say breakout of loop? I am frazzled. Just tons of messy code right now I'm dealing with. But I think we're getting there. Okay, so we can zoom into this. And oh, again, this bug is back. Okay. This bug is back. I think we need to put it back. Put the fix for that code back. It's probably because even this branch needs this fix. So I'm going to do it like this. This feels fast now, so this is good, and we also fixed the zooming bug, but I would say though, even with this optimization, it's still not as fast, as smooth as I would like. So I'm gonna do another performance CPU profiling reading here. Let's zoom out first. Okay, stop. And now I want to see what are the slow parts, and perhaps we can. I have a feeling, and doesn't look too bad to me, which is good. But I'm sure there's still room for improvement for the rendering speed. So let's drill into it and see here. We still have some measure text happening here. I guess one thing I want to know is whether it is going through this fixed width path or not. So I think I'm actually going to print out this fixed width property. Oh, one thing I would say though is every time there's a new font setting, it's gonna need to call this measure width once, which is gonna incur 43 milliseconds, which is not insignificant. Oh, it said fixed width true. Okay, fixed width is true. But yeah, but we still have to call that guy, even though fixed width is true. I suppose it would be better if we could just tell it that fixed width is always true. Instead of it having to figure it out. So maybe I'm just gonna, yeah, pass it in as a boolean. And then I'm gonna remove this code here. And yeah, I guess the fixed width can be passed in as a boolean here. Wait, why does this guy even have a default value? That don't make no sense. Okay, you're gonna tell me whether it's fixed with yourself, and I'll say yeah, it's kind of. There's a font weight, which is normal, and okay. I'll just tell you that it's a fixed width, so you don't have to wonder about it and try to figure it out yourself. 103, this I need a comma here. Okay, that's good. And now it should not have to call a function. Wait. what's going on. You're gonna pass in whether it's fixed with or not, and this guy is saying if it's fixed with, I'm just gonna do that. Oh, I see. Oh, I'm gonna still have to call measure text though, even if it's okay. I can't actually avoid calling measure text at least once, unfortunately. I'll reduce, but I'll remove one of them. Okay. Alright, let me try it again. Actually, I'm gonna start from the beginning so that the text measure doesn't have a cache yet. Okay, start over, record, zoom in. Okay, we're at the bottom now. Let me stop. Alright, I'm gonna check on the stream. Stream is in excellent condition. That's good. Okay, so it's loading the profile. Let Chrome do its thing. Okay, let's drill into here and see what we got. We still have these red slices, and still measure text is happening somewhere in there. I think it's because it's having to do that because we're doing a set font. Oh, we might be able to sidestep this actually, because it might be possible that this font has been already been cached. So I'm actually going to do this. Yeah, I feel like this can be optimized further. So I'm gonna try that and then do it again. Well, it still could be better, I think. It still doesn't feel like totally smooth. Not to the level of a baby's butt just yet. But it's not bad. It's not bad. I guess to a good measure of how good it is the render time, which right now is 100, a little more than 100 milliseconds. In some cases, a bunch more, 163 milliseconds, 166 milliseconds. That's the worst one. Still largely due to measure text having to be a part of the equation. Actually, if we didn't have measure text at all, we would be so happy. So let me think. Perhaps another way we could another idea for optimizing this even further, because measure text clearly still is the main bottleneck. Look how much of this is being taken up. Oh, there's one little slice that's taken up by fill text, but it's still measure text is one. Okay, I'm gonna add it up to be more scientific about it actually. So 2.8, 1.7, 18, 1.7 plus 2.8 plus what was it now? 18.65, 18.65 plus 7 point something, 7.51, 25.59, 10.02, there's been a couple of fill text, measure text 2.9, 1.91, 1.60, 72. It's around 72 out of 154. So 72 divided by 154 is about a little less than 50% of the overall time. Oh, there's also some time being taken up for set font that's not due to it. It's taking 7 milliseconds. That's not due to measure text, which is instructive there as well. And then layout is happening there. Layout happened again. Render, my layout time is actually still not a huge portion of all of the time. That's my code. Whereas fill text, it looks like the next bottleneck. And there's a little bit of time here in the set font, which I don't know. I guess it might actually be this line, or I suppose it could be this string generation line. If it's in the case that it's not doing a measure text. This one is. Okay. So I think it's worth it to still try to get rid of measure text by any means possible. So another idea of getting rid of even more, um, I guess, usages of measure text is, I guess once it's been cached, it'll be better, is one thing. So I'm gonna try it again then. So after I had already done that one time, the second time should be faster because all of that would be cached. I don't actually have to remeasure the text anymore the second time. Let me see if that's true. Ooh, I don't know if that's true. Oh, that's fill text. Still a little bit of measure text going on here. Oh, I know. It's because we're not reusing the same text measurer across multiple calls. which is what we need to do to really take advantage of text measure. So let's do that. Okay. Yep. So we shouldn't create a new text measure per call to fit box. That really defeats its purpose. So we should reuse the same text measure across all of them. Let me do that. Okay. Can get rid of this render function. Okay, so let me 397. Okay, so this one I'm gonna feed the text measure to this method, and the text measurer kind of makes the API less clean, but we're going to live with that for the goal of getting a good performance, because it's used as a cache basically for all these measure text calls. So now I think the cache should start working, and we should, after once of going through this, we should see better performance. Do you feel it's better? Maybe? Okay, we're at the bottom level. I don't know if it's that fast. It's probably not that fast right now. But it's bearable. But I want it to be blazing fast. I want it to be so silky smooth that it's ridiculous. But we're not there yet. We still have some calls to measure text happening, even after we share the text measure across multiple calls. And some of the ones, in this one, even when the measure text is not that big a part of it, we still have things that are happening kind of slow. So that's something I want to look into as well. But I still want to find opportunities for measure text. So I'm gonna do the thing I was planning to do previously, which is actually try to see if I can use, instead of for every single font size, call measure text to get the measurement for that font size. I am actually wondering whether I could generalize and measure for one font size and use that as the basis for all font sizes. That's somewhat dangerous, I must say, but you know, I don't know. I want to at least try this idea. Okay, so I guess font size. Okay, I'm gonna loop through again. I'm gonna use this loop strategy, and for each font size, let's say, yeah, for each font size, I'm gonna measure the width of some character. It doesn't matter which one. I'm not gonna try to do my width. Okay, I think that's good. Okay, I'm gonna. Oh no, this is not this. string. Okay, I'm just gonna measure the width for all these different font sizes and see if there's like this constant. So 5 goes to 3.0000488. So if I take this number, if I take this number and multiply it by 10, no, like 2, I get 6.009765625. It does seem to generalize. And multiply by 3. 9.00146484375. Yeah, it does seem to generalize, actually. And I know for the inconsolata case, it did seem to generalize as well. Where over there it was simply divided by 2. So you could say if you took the font size, which in the case of okay, or maybe I should do multiply this factor. Okay, so this guy is the factor. They're going to multiply whatever font size by to get the width. And we could just calculate that once and reuse it forever if it's a constant. So 125, we're going to get 75.0122070331. Yeah, that seems correct to me. Go to a larger font size. 445. 445, got 267.043. It's not exact. Wait, 0.04345, 0.04345, 7. Yeah, it's actually, yeah, I would say this is good enough. Yeah, I guess I will try, if I change this to inconsolata, then we will see the same deal, but in evener numbers, right? It's just divide by 2 for inconsolata. I can do Courier. For Courier font. Oh, Courier font is same. Okay, so we're gonna go with that. Okay, I'll undo this back to Monaco. We might try inconsolata later. See how it looks. Okay, so that's what I'm gonna do actually. So I'm gonna. I might even cheat, but and say if it's a fixed, okay, fixed with font ratio is a number. if it's we're just gonna calculate the fixed width font ratio one time. For a given font family and weight. Okay. So like instead of this stuff, we're gonna say well, T is the combination of the font setting dot weight, font setting dot weight, and font setting dot family. That's the key into this ratio dictionary. And so if there ain't no entry in there, if key is not in that dictionary, then we're going to calculate it, and we're going to calculate it by asking the context to measure the text for us. For the character I, it don't really matter. We're gonna use I'll just pick a font, let's say 10. We kind of already did that actually. Okay, we're gonna do it like this. This dot tx. Oh, this is the one I wanted to move out. Okay, so we're gonna do it like. We're gonna change the context as font setting to like 10 pixels for that weight and family. And then we're gonna measure its width, and then whatever the width is gonna be, you take a font, it's gonna be basically the resulting width divided by the font size. So this is divided by the font size, which is the font setting dot font dot size. That's the ratio. And we're gonna stick that in this dictionary. Equals ratio. And once we have this ratio, over here we're just gonna use this length times whatever this dot fixed with font ratio, look it up by this combination times this dot font setting dot size. Ratio, I'll extract ratio into a name. So that ratio times the font size is the width, and then I'm gonna multiply by the length of the text, and then this guy still applies. Yeah, I think that works. I'm not 100% sure, but let's try this out. This dot font setting. This dot, I set font setting 979. Yes, I did mean this dot font setting. Thank you, sir. Okay, still have, okay, that compiled. Let's see this. See if it goes fast. Oh, that's, okay, I'm gonna revert this code back to what we had before. Oh, good God. That's not good. Yeah. Okay, so I think what we need is, the reason this didn't work is because we had a render call, and right before the render call, we actually need to set the context, otherwise it's not gonna work out for us. Okay, try that. Boom. Kinda. Oh, this looks weird, actually. I'm not sure about this. Although, oh, wait a minute. May review text. Let me see. So this is the ratio. Oh, I used 10 as the ratio. Okay. This ought to be 10. Yeah, this ought to be 10. Yeah, I think I did it. Okay, so this looks good again. And I would expect the measure text call to be much more infrequent now. Okay, let me see that. Okay. Wait, is that bug back? No, I don't think it depends on it. It doesn't need this fix anymore because it does take the font size into account now. So yeah, so this guy can be moved in here now. And actually, we can revert back to having a return here and having a return here. here could just do, I guess I'll do that. And then return this, remove this return statement. See if that works. Okay. I think that would solve that problem. Maybe. We will see. Okay, this does feel like quite a bit faster, but it probably can still be better. Okay, I think I solved that bug once again. Okay, let's do another CPU profile reading. See where we're at now. Okay, true. All the way in. Okay, the base case. We are there. Gonna check the stream quality here. It says excellent condition. Great. Okay, that actually... Alright, I'm gonna still go for the largest slice, which was 200 milliseconds, but some of these slices are 43 milliseconds, 50, 70, 96. There's still some longer slices, but the thin ones are promising because this one is 92, but this one is 42, etc. Okay, I'm gonna take one that's longer, maybe in here somewhere. 248. God dang. But I would assume that none of it has to do with measure text, and I'm totally right in that assumption. There's a minor GC here. Now the bottleneck has more to do with the rendering, these render text calls, and also this layout algorithm that I'm executing here. So, what should we do about that? So the previous idea of having a current scope and only laying out starting from the current scope, that still applies. So we could use that approach to optimize this stuff. Another idea is to only render the text that is actually on screen. And I believe that's not done currently, right? So let me think. The fit box algorithm. Yeah, the fit box algorithm, let me think. We're always starting at the top level scope, and we always render the text whether or not it's on screen or not. And that's actually kind of dumb. However, the idea of keeping track of a current scope and only layout starting from that point would also kind of solve that problem in one shot. So maybe we do go for that approach to get two benefits, to hit two birds with one stone. That way, I feel like that's a pretty good solution. Because that would mean, for example, whereas the top call to render frame entries is for the main function, so like if we zoomed in here, this guy is for, say, the main function. Yeah. I wonder if the streamer when I zoom in the screen like this, whether OBS takes that in okay. I'm gonna watch myself. No, it totally does not. Okay, I'm not gonna do that anymore. Okay, so I'm gonna do it. I mean, I could maybe zoom. Well, I could take a screenshot here. Yeah, I'm gonna take a screenshot here. Open it up, and then I will annotate the screenshot. Annotate the screenshot. It's assuming I can find it. Okay. Ooh, that's quite good. Okay. So, what I wanted to say was like this render frame entries. It's going to be called for the main scope, and then the main scope is gonna call render frame entries for the FIP7 scope, and then the FIP7 scope is gonna call it for probably the FIP6 scope. I was expecting to see another one. Not sure. Maybe it's this one. Maybe it's this one is the FIP6. I'm not sure. This is FIP5 maybe? Not totally sure. I'm actually going to investigate. No, that's Fitbox actually. Okay. Maybe I should actually look into this. So main scope and then FIP7 scope, and then inside of FIP7 we have a call to FIP6 and FIP5. So main, oh, maybe this is main. Yeah. This is like outside of main, maybe. And then this is main. And then this is FIP7, and then this, okay. Okay, so this is outside of main. Outer of main. It's just a box, and then we have main. And then we have FIP7, and then we have FIP5. Oh, it starts with 6 first. FIP6, and then this is for FIP5. You can't see this anymore because of the color, so I'm gonna write until the color is visible. Alright, so this is FIP6, and then we have FIP5, and then lower down here we have FIP. For FIP6, we're gonna need to have FIP5 and FIP4, I believe. And then FIP5 is gonna need like FIP4 and FIP3, and so forth and so forth. If we keep track of what is the current scope, say if we zoom so far in that this scope contains all of the current visible viewport, then we don't actually have to execute any of this code. This can all go away. Even this stuff, well, I guess this stuff can go away. So the execution time would end up being just this chunk, which will be great because so like the execution time of the whole thing currently is 248, and the execution time of just this chunk is 136. 136 is still a little slow, honestly, but if we can get that will give us a huge bump, and a lot of the other ones aren't even that long, quite a bit shorter. So this is only the longest one. Okay, so I would say that's the next strategy. Next strategy for the performance work. So I'll say we did some of this more. So it did some, have more to work on. Okay, I'm gonna take a break now. I may or may not continue after my break. I will see you